Hi everybody, hi everyone here. Well done for coming in today at, I think it was pouring at one stage, right? So if you went through the rain and got here, thank you. If you're at home, hello. Yeah, it's week 4 already. Today we're going to do a bit of a recap on arrays and do an example with an array of structs. It's basically the same thing. It's still a 1D array, but I know when you're just learning structs, it seems like a kind of difficult, more tricky thing. But it's really the same thing. Then we'll look at 2D arrays, which are a bit of a different thing. Okay, yeah, and last week we talked about functions, so I hope you're sort of getting your head around functions. It takes time to sort of really understand these concepts properly and then also be able to apply them yourself, right? So just keep practicing. We also talked about 1D arrays, which we'll recap, and a bit about style. Okay, this is just an announcement. If anyone feels like they're struggling with any courses, not just this course, this Sunday is the census date. It's the last day to drop a course without financial liability. If anybody's not sure or is concerned or confused, just come and talk to us as well. Let me know. And that's for other courses too. Okay, assignment 1. So it will be out today at 1 o'clock after this lecture. So it's an individual assignment, so there won't be pair programming with this, just to make that very clear. You will be using arrays, and specifically you'll be using 2-dimensional arrays as well, which we're looking at today. You'll be doing problem solving, coding, using functions to make sure you've got good style, so you don't have, hundreds of lines of code in your main with copied and pasted duplicated code. And you're going to spend a lot of time debugging, I would imagine. So it'll be really testing your patience and perseverance, and it will really be developing all the skills you need. And think of this, every minute you spend on this assignment working on it, you're learning and you're improving, and it's like you're already studying for the final exam by doing this assignment, because the final exam's a programming exam. So every minute you spend, you're studying already. There will be 20% of your mark will be for style. So there'll be a rubric that you see which will show you exactly what you'll get for what type of thing, like comments might be worth X marks, indentation will be worth however many marks. So you'll know exactly what we're looking for. You've got your style checker that can help, but you'll also have to, there are some things it can't really pick up. If you're not sure, if you're thinking, I'm not sure whether my comments are good or there's too many or not enough, that's something you can always ask your tutor about. Show them your code and say, what do you think? Or in a help session, what do you think of these comments? Or whatever it is you're not sure about. The other thing people often ask about is, well, what's the other 80% of your mark? Well, that's basically on your code performance. So we do run auto tests, like with the labs, and we do run extra auto tests. So ones you haven't seen, auto marking tests, that might have slightly different test cases than what you've tested. And especially for the later stages, there might be cases in there that you haven't thought of. So if you get all the auto tests working, fantastic. Then we encourage you to do some more testing as well. And that's going to depend on how much time you've got, and but that's the ideal situation. And a human will be reading your code, right? Your tutor will be reading your code. So if there's like little things you've done that has made it fail a test here or there, they'll look through that to make sure you get a fair mark. Okay, so these are things that often people might stress about. All right, there are 4 stages. It's a bit like the labs where the first 2 stages are a little bit like 1-dot exercises. Oops, I forgot to turn my Teams off. No, that's me. Actually, I'll turn it off now. Just wait 1 second, everyone. That's my fault.
Just send assignment solution in chat.
Yes, that's what, yeah.
On projector for all students.
Hang on, I can't even, I'm just so distracted now by myself that I can't find the right controls. I'll just turn this off while I shut my Teams. I'm so sorry. No, that is 100% on me. Okay. Sorry guys, I'll be back in 1 second. Okay, we're back. Okay, so yeah, sorry about that, everyone. It's a little bit like stage 1 and 2, a bit like the 1-dot lab exercises. Then stage 3 will be a bit harder, like the 2-dot exercises. Stage 4 is going to be like the 3-dot questions. So if you're not doing the 3-dot lab questions, which, you know, they're very challenging, they take a lot of time, not everybody does them. I'm not sure of the exact statistics, but I'd say a lot of people don't do them, certainly not every week. So lab 4 is meant to be really quite challenging. If you don't get up to it or you can't do it, that's not reason to panic and think you're going to fail the course, okay? And you'll see the mark distribution. The most of the marks are for stage 1, a few more for stage 2, a few more for stage 3, and just a small amount for stage 4, okay? So don't panic about stage 4. But stage 4 is a great challenge if you've got the time, and everyone's got different workloads and different lives, different interest levels. All right, there's a live stream tomorrow at 12:30, and John, who's our lovely cameraman, will be running that live stream. And there's a YouTube link here, and I've sent it in an announcement on the forums as well. So it's on at 12:30. He'll be running through more details about the assignment comes out. So you've got questions ready to go, because you can ask on the chat in the live stream. If you can't go at 12:30 because you've got other things in your life, there will be a recording as well. And you can also ask questions on the forum as always too. So the earlier you think about what questions you have, the better it is, you know, get them out there. It will be due Monday, week 7 at 5 p.m. So you will have flexibility week to work on it, but I don't advise leaving it to flexibility week to start it, okay? So I would start it early. A first step is to actually understand what you have to do. Don't jump in and code before you know what you're trying to code. Go to help sessions early before they're busy, which they will be in week 6. All right. I hate having to talk about plagiarism, but every term we do get more people plagiarizing than we'd like. I mean, we would like nobody, but we get, you know, more than we hope we'll get. Make sure you get help from the right places. So if you're getting help from a member of staff from this course, that's probably going to be a good thing. They're probably not going to give you too much help and give you the answers or something like that. Sometimes people get caught out going to external tutors and getting a little bit too much help, and then somebody else goes to that same external tutor, gets a little bit too much help, and then they're flagged for plagiarism and they're in shock. Well, yeah, just be very careful. You're supposed to write the code yourself. Get help from an external tutor to help understand concepts, but don't be typing in any code or copying code, you know what I mean? I hope everybody kind of gets the difference. Same with ChatGPT. If you think, oh my goodness, I just typed one of this function and ChatGPT wrote it, you can bet there might be hundreds of other people that might do that too, you know. So this does come up. We do catch people. Often the penalty for something like this might be 0 for the assignment, but it can be more, and you can end up on a plagiarism register. So it is very serious. There's more details in the course outline and on this link. So this is just to make sure you don't get yourself in trouble, first of all. Second of all, what's the other benefit of not plagiarizing? Other than not getting stressed and in trouble and losing marks, what's the other benefit? Yeah?
Learning.
Yeah, learning. I think I said before, it's like if you've got a marathon and you get your friend to train for you, you know, while you're eating, while watching the TV. That's something I would probably do, but it's not going to be very helpful. All right. Did anyone go to the revision sessions this morning? There's ones at 9 to 11 in person. 25 people. Oh, that's awesome. Well done for turning up at 9 a.m. And if you've then doubled up and come to the lecture straight after it, yes, good luck. There's more. So there's a link where you can sign up to go, Wednesday 12 to 2, Friday 12 to 2 online. Okay, and I think you can still vote for your favourite topics, or maybe your least favourite topics that you're not understanding, whatever you want to see covered. All right. Any questions about any of this before we move on? Okay, well, let's get... Oh, here's a disclaimer from me. Now that we're talking about style you're going to be marked in the assignment, just be aware sometimes in the code that I put up, that I'm typing in the lecture, I might type in something to answer a question and show somebody something, you know, weird or strange, or I mightn't then properly comment it. So I'm just giving you, like some of the code there mightn't be 100% perfectly styled and polished. And sometimes I put comments that you mightn't put, like maybe a comment trying to teach you what some function, like something in C does, like x plus plus is the same as x equals x plus 1. Now, obviously we don't want you to write comments like that, where you're explaining C to the person reading it. But again, if you're not sure about comments, whether they're good, bad, or otherwise, ask your tutor, get some feedback. Okay, so let's go back over arrays, just one-dimensional arrays. So in this example here, I've got this array. What's the name of the array? Yeah, chocolate eating. What type are we storing? Int. So the first thing is the type. The next thing is the name of the array. The next thing is what? The size, yeah. How many integers are we storing in this array? And what's all this weird stuff here? We call it like a static initializer, but that's just saying I actually want these numbers in my array. And we can see down here, we've got a visualization of it. So often we'll draw these things when we're trying to work out what we're doing. And they're all integers, they're all packed together in one chunk of memory. And the indexes start at 0 and go up to the size minus 1. So there will be no index 7. We've got indexes from 0 to 6. Okay, is everyone clear on that? That's something that people get confused about, because usually people have a tendency to start counting from 1, right? But we start counting from 0. All right. Now, I've only got one variable name for my whole array, but I've got lots of data in there. So to access the individual elements, I use the index. So if I go to index 2, I'm going to get this item. So I say chocolate eating at index 2, and that takes me to here. If I said chocolate eating at index 6, I would get this element here, right? If I said chocolate eating at index 7, what do I get? I get, my program will crash if I run it. DCC might notice and try and warn me, but yeah, not good. There's nothing there. Or there might be something there that you're destroying, you know. So yeah, we don't want to do that. Now we don't, like the whole beauty of the way that we store this in an array is that it makes it really easy for us to use while loops to go through it. So if I want to look at every single element, I don't need 7 printf statements to print them out individually that I have to copy and paste. I can use a loop. And that's because if we're traversing our array, which means going one by one through all the elements, I'm going to want to start at the first index, which is 0, and then I'm going to want to go then to the next one and the next one and the next one, up to but less than the size, right? And that's really easy for a while loop to come up with these numbers, right? So hopefully everyone by now can do a while loop where you generate the numbers 0, 1, 2, 3, 4, 5, 6 up to some limit. We just have to do a while loop like that and use those numbers as our indexes, okay? So here, we're starting with I is equal to 0, and we're printing out chocolate eating at index 0. But then we increment I, and then we print out chocolate eating at index 1. So this I keeps changing, and we keep printing out the next element, and the next element, and the next element. When I is equal to 6, and we increment it, we're going to get 7. 7 is not less than 7, and the while loop finishes, and the code can continue after the while loop. Is everyone sort of happy with that? Any questions? Okay. So what we're going to do, we're just going to do a few coding exercises now, because we did a few coding exercises last week, but we didn't start putting things into functions. So let's give that a go. All right. I'm going to call, is this big enough? Okay. I'm going to call my array just data, and I'm going to make it size 3. Okay, I've got a hash define up there. I've got an array of size 3. So at the moment, if I wanted to draw a picture of it, I've asked for a chunk of memory of size 3, and it would have these indexes. And what would be in it at the moment? What data does it have in it? Just garbage. It's uninitialized data. So right now, if I tried to print something, if I tried to print a piece of data from this at the moment, what would it do? What happens when we try and print a variable we haven't initialized? Well, DCC is warning us. It already knows we've got uninitialized data. If we ignore it, yeah, we get a runtime error. Who's had this error before? Not from an array, just from variables. Yeah? Okay. All right, now if I wanted to, we've seen the syntax. I could do something like this. And put some data in there. let's just try that for now. Now we've put the data 4, 6, and 7 in there. Okay, so now if we printed it out, it should be fine. Let's go and do our loop again to print out the whole thing. So remember, we want a loop that starts at 0. We want to start at index 0. I is a fine name for this. We say in general don't use variable names like I, but it actually has meaning within the programming community. I for index, you use it in a loop. So this is one case where I is fine. All right. We're going to less than the size of the array. So we're going to less than 3 in this situation, which should give us indexes 0, 1, and 2. And each time, hang on, I'm printing. I forgot what I'm doing. Each time we're just printing out our element. Now this is an array of ints, so every item or piece of data in there is an int, so we use %d. The name of my array is data, and I want to print out the one at index I, right? And then I'll change I and it'll print out the next one and the next one. Is everyone sort of okay with this? Any questions? All right. Great, 4, 6, 7. Maybe I could put a new line after here. So I don't know whether you prefer fors or whiles. I might leave this one as a while and I'll do the next one as a for. Now, if I want to move this into a function, I'm going to create a function called print data. What's the return type of this function going to be, do you think? Yeah, void. I'm not asking for any answer to any question. I'm just saying go and print this data for me. And what inputs do I need to give it? Is everything all right?
Yeah, I couldn't find the person to give chocolate to.
Oh, okay, cool. Don't worry, everybody. I just was distracted. What input do we need for this print data function? We need to pass in the array. What else? We have to have over there. We have to have some way of the function knowing how big the array is. So there's a couple of ways we can do it. One way is to actually just pass in the size and then also pass in the array. That's what we'll do in this example. And you'll sometimes see it like this, but we'll put the size in here to imply you're supposed to pass in an array of that particular size. So that's the prototype. I'm putting this down here, and I'm going to take all this code away from here, put it in here. Now, instead of using this constant, I want to use the size that was passed into me. I want this function to work even if I used it with an array of a different size. Okay. All right. And now I have to actually call the function. So I'm going to say, go print the data. Oops. This is the size of my array, which we know is 3. And this is my array. So it passes in that information. And this will be important later. When we pass things into functions, remember, if I'm passing in just an integer, it gets passed in by copy. It's just going to get a copy of the value 3, right? When I pass in an array into a function, it actually gets access to that original array. It doesn't pass in a copy. All right, that'll be important, maybe not so much for this example. Okay, so that's just going to print out 4, 6, 7, but we've put it in a function. Let's jump straight into writing a function for something else. Let's try let's just try one to read the data. And I'm assuming I'm not doing error checking in this example. Like I'm not checking that I really read in integers or anything like that. Now, something's really doing something over here. I can hear all the... Yeah, all right, I'll ignore it. Now, when we're reading the data, we're still going through the array from beginning to end, right? One by one. So we're still basically using this same kind of loop. We're still starting at the beginning, going one by one, but instead of printing it, what are we doing? If we're reading data in, instead of printfing, we're, scanfing. And if I'm scanfing, what do I have to change? Yeah, I have to put this ampersand there. Okay, so once you know how to traverse the array with a while loop or a for loop, it's the same thing. This can apply to many different functions or problems that you have to write. You just have to modify it a little bit. So let's try our read data. And yeah, this read data is just going to destroy the data we've got in our array. Right, I've already put data in there. I'm just going to read over the top of it. If I can type it in. Okay. And then maybe I should print it again, just to show that it worked. So we're starting off. Printing out what's in the array, which is 467. Now, look, I haven't prompted the user, but since I'm the user, I know I'm expected to type in data now. So I'm going to type in new data 8, 9, 10. And scanf, and this is just a reminder too, when we're doing scanfs, anything that I type in will just get put in a scanf buffer. So the first scanf %d will read in this 8. %d skips the spaces. And it's going to put it into here because that's what my code's told it to do. Next time round, I will be 1. This 9 and 10 will still be waiting for scanf to scan it in. It's going to read in the 9 now and put the 9 in here. Then it will read in the 10. So I think that's something that people have found tricky about the custom cake exercise. That you can type in a lot of data and it just sits there waiting for scanf to read it in. Okay. So I'll press enter and scanf will go through that loop 3 times, reading in. Oh, what have I done wrong with scanf? Has anyone done this before? Yeah, I've got this space here, which was fine because when I did printf, I wanted to print a space, but stuff like that in scanf just does weird stuff. All right, let's try again. I'm going to press 8, 9, and 10, and that loop will go through 3 times doing scanf %d, scanf %d. Yep. Go up the top? Yep. That's okay. So again, I'll just do it 8, 9, 10. We're printing out the data. Then we're just completely overwriting that data that we had with new data, whatever I type in, and printing it out again. Yep, question? If I put a space before the %d, oh, I don't usually do that. I'm not sure. Scanf has so many specific features. Oh, I've just done it for the printf. Ugh, I'm sure about what that does. But yeah, it can do weird things. I'm not sure for %d because usually I wouldn't do it. But yeah, we can try it. Well, we can look it up later as well. So if I just type this in, okay, that works. But after it doesn't. So I can look that up why and sort of give a detailed answer. All right. What are we up to? Okay, the next function we want to write is print odd data. So let's give that a quick go. Print odd data. Sorry if I'm typing quickly. Now, when we do print odd data, it's going to be very similar to what we did for print data. We're still going to go through our array one by one and either print it or not print it. So what do you think we can add to this code to only print the odd data? Yeah, so we could do an if statement, right? So before we print it out, I could say something like, if the data I'm about to print out, and to check if it's odd, I can say, I can do a mod 2 and check it's not equal to 0. If it's equal to 0, we know it's even. If it's not equal to 0, we know it's odd. Okay. Now, if you do it like this, that also means it's odd, but it's only going to work for positive odd numbers. Okay, if we do it like this, it'll work for both. So that's something you can try out. So let's have a go. I've actually got to print it. I've got to remember to call this function. So I'm going to do print odd data and call this function. Let's see if it works. All right, I'll just type in the same thing. So it should just print out the 9, right? Yep, it does. If I run it again, let's try it. With some different numbers, it should print out -7 and 99. Okay, so again, we're traversing the whole array from start to end, but we've got an if statement controlling whether we do something or not. Again, this is a common sort of pattern that you'll see in your coding. All right, one last function. I want to find the maximum in the array. So if I do that, that's not how you spell maximum. What would be the return type? I want to find the maximum. Yeah, so I could do int. So I'm asking, here's an array, this is the size of it, what is the maximum sort of thing? Okay, we're going to do that. And because I'm sick of typing stuff in, I'm not going to read the data in, I'm just going to hard code some data. That will do 1, 2, 3, 4, 5, 6, right? Let's just check it still works. Yep, it prints out my data, which is my new data I just typed in and hard-coded in. And it prints out the odd ones, but now we want to find the maximum. So any ideas about how we could find the maximum in this array, yeah?
So we assign the first element to a variable.
Yep.
We go through the array and there's a number bigger than the first one, we replace it.
Okay, that's an excellent answer and definitely deserves a chocolate. I'll repeat the answer. So what we do is we can look at the first one and we can say, okay, the biggest I've seen so far in this array is 4, because it's the only one I've seen so far, right? Then I check the next one. I go one by one and say, well, is 6 bigger than 4? Yes? Okay, well now that's the biggest one I've seen. That's the maximum. But I keep looking, I have to look through everything in the array. Is this one bigger? Is 7 bigger than 6? Yes. Is this one bigger? No, minus 3 is not bigger than our current max, which is 7. Is 9 bigger than 7? Yep. So that would now be the current maximum that we've seen so far. Is 2 bigger than our current maximum of 9? No. So that's our approach. So again, we're going to have the same loop traversing from beginning to end basically, but now we're just going to have an if statement in it. So let's try and code that up. And that's common as well, finding the minimum or maximum. You do the same thing for minimum. Well, that was a bad idea. Find maximum. Apologies for my scrolling.
To print out the maximum data and the maximum value, and only the maximum value, you need to store it in the variable in the read void. Do you?
Oh, so what we're doing now, the question was about how we're going to actually print out this maximum when we get it. What will, we're writing a function that returns a number. So it's like me saying, what's the maximum? And you returning the answer 9 to me. And then I can do what I want with that value. So back in the main code, we're going to call this function and we'll say something like int max equals find maximum. We'll pass in the size of our array. We'll pass in our array. And that function will go and find the maximum. We can put it in a variable. We can print it out. We can do a calculation with it, whatever we like. If we'd done find maximum as a void function, which some people would be tempted to do, you could print it out in there, right? You could just find it and print it in that function. Actually returning it to be used as data in the main is sort of more powerful and gives you more flexibility with what you're going to do with it. Okay, and then in here, I could then say the max was right. So we're going to get our find maximum function to return it, and we'll print it in the main. All right, but let's finish writing it. So I'm going to have my max, and I'm originally going to make that to just the first one in the array, and that's at index 0. But now I'm going to search through one by one and see if any of them are bigger than it. So I need to change this if statement and what I'm doing inside it. So what do I put here? If the one I'm looking at, yes, I can hear a few things with different people saying slightly different things, but I think, yeah, you could be checking whether data's less than the max, or you could be checking whether it's greater than the max. It's sort of the reverse logic. But let's just check if the one that we're looking at, so just so if I'm up to index, if my max so far is 4, and I'm up to index I is equal to 1, I'll be comparing 6 to 4, right? The current one, imagine I'm up to index I is 1. I'll be comparing the 6 to the 4, and I'll be thinking, yeah, that is bigger than 4. 4 is not the max. This one's the max. Right? But then when I get up to I is equal to 2, I'll be looking at the number 7 and going, well, 7 is bigger than the max, which is 6. 7's the max, and I'll be putting that 7 into the max variable. And I just keep doing that. Now, if it's not, if I'm looking at the number 2 and 2 is not less than 6, I do nothing, I just move on and check the next one. Okay? Does that kind of make sense? And by the end of it, what do I have to do if I've got a function with the int? I've got to, return some integer, hopefully that is the max. Now this will work. Oh, well, listen to me, a bit overconfident. Let's try it. It should work. The max was 9. Yeah, a question?
Could we not use printf max instead of return max?
Yeah, you could use printf max and just print it out here, but then you've got a function that's less useful. If I return it, this could be used in lots of different places. They could choose how they wanted to print it out with different wording. They might not want to print it out. They might then want to do a calculation with it. So if you just print it out, you're limiting the options. The other thing with this is, and this doesn't really matter in this course, but can anyone see how we could make this a little bit more efficient? Are we checking anything we don't have to check? Yeah, so when I start, and this is perfectly fine how it is, but when I start, I set my max to be 4, and then my loop checks the first element and checks it if it's bigger than 4. You know what I mean? So I don't technically have to check this element because I've already assigned it to the max. So yeah, don't worry if you're confused by that, but yeah, you could potentially start that at 1. It's still going to work, and you've just saved the work of checking one thing again. In future courses, that would be, maybe important to do. But I just wanted to point it out. Actually, yeah, let's just put it in there. Okay. We're just saving one comparison. Now, are we sure that this maximum function works? If you'd written this function and you just tested it like that, would you be sure it works? No. You'd have to do different test cases. What if for some reason it only works? What if for some reason you're out by 1 and it doesn't work if the maximum was at the beginning? Or if you're out by 1 and it doesn't work if the maximum's at the end? Or it doesn't work if all of the numbers are the same? What if all of the numbers are the same and you'd put some sort of logic in there? You've got to check all of these different cases and think about the different cases you want to test. And we don't have time to test them now. If anyone finds that this is wrong when they go home and test it, just tell me and you can get chocolates. All right, we're going to move on now to a struct array. Now this is still a one-dimensional array. Is everyone ready for this? I guess it's too bad if you're not, because we have to do it. So everyone, this is exactly the same thing as an array of ints or anything. So we've just seen if I was going to do an array of ints, I'd say int nums 5, for example. This would be my type, int. I'd be asking for an array that could store 5 integers. Here, I'm asking for an array of type struct coord. So that's just the type. Now, what is struct coord? It's a struct that we've made up. So the type is struct coord. It's got 2 members, an int x and an int y. So is everyone sort of okay with that? Our variable name in this situation is just map. This is just the name we've given it. The size of the array is 5. So we're going to end up with an array big enough to store 5 of these structs. And as always, our array index will begin at 0 and go to less than the size. So there'll be 0, 1, 2, 3, 4. We've got these 5 structs. Now when we've done this, again, they're just going to be undefined. But on this next line, we're actually setting some data. So that's kind of a two-step thing. I want to go to my array at index 0, and that's going to give me a struct. Yeah? Just like if you go to your array at index 0 in an integer array, you'll get an int. Here we get a struct. But if I've got a struct, to set the data inside it, I have to set the different members separately. So I'm saying map at index 0, that'll take me to the struct, and I say .x, that lets me set the field to 3. I say map at index 0 .y equals 1. Okay, if I was going to set this one over here, I would do something like map, I've got to go to index 3, that's the one at index 3. I would say .x equals, I don't know, 0. That would put the 0 in for that member. I could say map at index 3 .y equals 7, for example. Okay, it's the same principle. It gets just trickier because you've already sort of, just learning structs. Before we do some coding with this, does anyone have any questions? Yep.
Do we not have to specify the data type of this array?
Yeah, the data type of this array is struct coordinate. So when we're dealing with structs, these are user-defined types. These are types we invent, and we use the keyword called struct, and then we make up this name, and then we decide what can go in the struct. And when we define it here, we're telling C, this is a type we're going to use. We've now got ints, doubles, chars, and now we've made up our own one called struct coordinate, and that's the type that we've got here. All right? And I could make a different struct. I could have struct person, and I could have an array of struct persons. Does that make sense? So that's the type of it. Yep.
X and Y are never established to be arrays, right?
X and Y are not arrays. So what we've got an array of structs. Each of these is a struct. So just let's go back to struct. If I just wanted one struct variable, I'm just going to call it P. I could make a variable of type struct coordinate like that, right? And then if I wanted to set the X value in it, what would I do? I'd say P.x equals 3, for example. Now, in this example, I haven't made an array of them. I've just asked for one struct called P. I'm setting the X value to be 3. Then I could set the Y value to be, 7. Right? This is dealing with one struct. That's my type. That's my variable name. I've just got one of them. But in my struct, there's 2 places for data. There's places for an integer X and an integer Y. And I have to put them in separately with these dot fields, these dot member, I sometimes call them fields or members, sorry about that. So I'd say P.x equals 3, P.y equals 7. Is everyone happy with that? Now, when I've got an array of these things, I've got lots of these structs. So the first step is to use my array index to find the one I'm interested in. So, yeah, map at index, I don't know, let's say index 4. That takes us to one whole struct, right? And when I've got a whole struct, I can access the different fields. So I'm going to the struct at index 4. I'm going in and setting the X part of it to say 5. I can go in to that part of the array and set the Y value to something else. All right? So there's that extra step because it's a struct inside this array, and then you've got to assign the data to the individual pieces inside the struct. But the first step is going to the correct index to get the correct struct. Then going to the correct member to put the right data inside. Okay, any more questions about that? Yeah?
Would we be covering how to convert from arrays of structs to structs of arrays?
So you could have a struct with an array inside it.
Multiple arrays.
Yeah, you could have a struct with arrays inside it, and we might see that at some point, but not right now. Not right now. Let's have a 5-minute break. Let's come back at 12. I'll just do a little bit of coding with these arrays of structs, and then we'll move on to 2D arrays, which is kind of more crucial. But that'll give you a chance to sort of think about it. All right, we're back from our break. I'm just going to do a quick programming example with these arrays of structs. Not doing anything groundbreaking, just printing them out, scanfing them in, just to get a little bit of an idea. And then we'll move on to 2D arrays, which are really important for us to sort of do today. Okay. Oh yeah, here it is. All right, I've got pretty much the same scenario that we just had in the slide so that we're familiar with it. But, so all I've got is an array of size 5 called map. And you know, it's structs. So there's a place for an X and Y in there. Maybe I'll draw that. I don't know if that just makes it look messier or anyway. I want to be able to read numbers in to put in this array, and then I want to print them out. So when we read them, I've got an array, right? And I've already put this into a function for us. But I want to do the same kind of thing. I want to start at index 0, and I want to go one by one until I reach the end. So I'm going to start with my index at 0 and go up to less than the size of the array. Okay, so this is nothing new. This is what we did with the integer array. Now what I'm going to do is just print something out. Enter a point. It's not that helpful, but I'm going to print that out first so we know where we're up to. And then I'm going to do a scanf. So if I'm asking a user to enter a point, I'm kind of wanting them to enter 2 pieces of data, an X and a Y. And when I'm reading in 2 integers, I would just do %d%d. Now, if I was just reading them into some variable, I'd do something like that, but that's not what we're doing here. Remember, I'm reading it into an array. So how do I get the actual element in the array I'm interested in? Yeah, so I'm going to have, map at index I. That will give me the correct struct in the array. And then I'll say .x, which will give me the particular member I'm interested in setting. But of course, it's scanf. I have to put my ampersand in there. So that will, I'll show you in a second. And I do the same for the Y member as well. Oops. Okay. All right, does that look okay? I haven't done print yet. Should we try print as well? Print is going to be pretty much exactly the same thing. We're taking our loop that goes from the beginning to the end of the array, and one by one, we're printfing them. And because it's printf, I don't need that ampersand. But I'm just going to print, I will take me to the index or the particular struct I'm interested in. The .x will get the x member, the .y gets the y member. Let's try this. So it's enter a point. I'm going to type in 0. Oh, I can't type. Well, 9. I've typed in 9, 1. So this 9, you know, I is equal to 0 at the moment in here. So it's going to go to index 0 and this first 9 will be read in by this %d, and it's going to go to the map at index 0 and put 9 in the X member. Then the scanf is also going to read in this 1 and put that in the Y member, right? Then we're done with index 0. This will increment, and it's going to ask me to enter another point. Oops. Enter another point. And now we're up to index 2. Maybe I'll write this in. Naught, naught. That's going to go in here, etc. Actually, this is a lot of points for someone to type in. Okay. And our points have been printed out. They look pretty bad. Maybe if I did it again, I could make them look nice and maybe put a space in here and a printf at the end with a new line. But basically, we're getting all the data printed out. Let me try again. Struct array. And you know, even if I typed ahead of where it was up to, even if I thought, I'm not going to wait for you to keep asking me to enter a point, that would still work too. Okay, and then it's printing them all out. All right, are there any questions about that? Yep.
On line 28, will there be any problem if we don't fill the white space between %d and %d?
Oh, like this. Here? Everyone, let's try this. But we can still type it with space, yeah. Yeah, all good. By the default, %d will, skip spaces. Yeah, I have to look up what that trailing space does. I typically write it like this. I don't know why. All right. So look, you're going to see more of arrays and arrays of structs in the tutes and labs. So don't panic. You're not expected to now be an expert on working with arrays of structs. But hopefully they mean something to you. Let's move on to 2D arrays. 2D arrays are really cool and very important. Okay. Is everybody ready? All right, we've got plenty of time. This looks a bit similar to the declaration of an array. What's the difference? It's got an extra size, so it's 2-dimensional. So I've still got my type. So in an array, I can only store one type. I've got the name of the array or the name of the variable. But now I've got 2 dimensions here. And the 3, we think of that as the number of rows, and the 5 as the number of columns. So this can represent things like tables or matrix, boards, like board games. We often use some sort of 2D array. Very common. And you can have more than 2D arrays. You can have 3D arrays. We're leaving that for another course. 2Ds will be enough for now, I think. Yep. All right. So this is how we would visualize it. So I've got 3 rows. And again, the indexes start at 0. So this is row, whoops, I've gone forward. Oh, no, I haven't. We've got rows 0, 1, and 2. There's no row 3, right? just like if, you know, a one-dimensional array is size 3, you don't have an index 3. Then we've got our columns, which are going from 0, there's no column 5, right? Our indexes for the columns go from 0 to 4. Now, if I want to access an individual element, and all of these are ints, I have to give 2 indexes. So here I'm saying go to row 2, and this is row 2, column 3, this is column 3, and this will give me my particular integer. Does that make sense? Right? If I said, if I wanted to set this one here, what would the, what indexes would I need? Yeah, I would just say number grid 0, 4 equals 10 or something. And I could go and stick that value in there. Okay. If I said, let's go to number grid at index 3, 0, what would happen? Yeah, crash. If we run it, it will crash. We might get an error message and a warning, but it will crash. Same if we try and go to column 5, actually. With DCC, it'll crash, give us a runtime error. And it will say something like array index out of bounds or something like that. All right. Now, if I want to initialize all my values all at once, like we saw with the one-dimensional array, we can do that too. I like to lay it out like this, so it visually looks like the two-dimensional array I'm thinking of, rather than stick it all in a straight line, even if it fits. And we can see there's 3 rows of data, 1, 2, 3, 4, 5 columns of data. Okay? Is everyone happy with that? And it basically looks like how we're going to think of it in this 2D array down here. So that's another way you can do it if you know in advance what your data is. Now, how are we going to traverse this 2D array? How am I going to go through it one by one? Just say I wanted to print it out. Yep, question? Answer? Yeah, a nested for a while loop, because it's quite similar, and yeah, chocolates, quite similar to code we've written before. So imagine I'm printing this out, and I want to print it out. Imagine I wanted to actually print out the data. I'd want to go row by row. I'd want to start here and print out the 2, then the 4, then the 6, then the 8, then the 10, for example, right? I'd want to start at row 0 and go through all the columns. Then I'd want to move to row 1, go back and go through all the columns again, move to row 2, go back and go through all the columns again. And I'd be wanting to go to indexes like 0, 0, then 0, 1, then 0, 2, then 0, 3, then 0, 4, etc. And that's the kind of behavior, we had with a nested loop, right? So when we've got a loop like this, if we run through it, we start with row equals 0. We're setting column to 0, and we've got this loop, and it was printing 1, 2, 3, 4, 5. Then we incremented our row to 1. We reset col, and we're printing 1, 2, 3, 4, 5, right? So we've got this kind of nested loop that can give this behavior of going column by column and row by row. So here we go. We've got our two-dimensional array, which I've defined up here, and I've just got the visual representation down here, and I've got my nested while loops. And the main difference is the structure of those while loops is the same. In this case, my rows is a different size to my cols. So I've got 2 different sizes, one for the rows, one for the cols. And here, instead of just printing out what the row or col values are, I'm going to the array at that particular index. So let's just go through it. At the beginning, row is 0, col is 0. And we'd be printing out this first element, which is a 1. But now we're inside this while loop, the inner one, and we've incremented col to 1, but we're still on row 0. Yeah? Is everyone happy with that? So we started off, I'll just go back. Oops, I'm going the wrong way. I start off at 0, 0, and I print out the 1. But I'm now in that inner loop, and I increment the column. So now the column, I keep going around this inner loop, and I print out the 1 at row 0, column 1. Right, I'm still in the inner loop. I increment col to 2. I'm still on row 0 though. And I'm still going around this inner loop. And I keep incrementing col. Now when I get up to here, I've printed this out. I've incremented col. Col will now be 4. 4 is not less than or equal to 4 is not less than 4, so this while loop stops. We'd get a new line character, and we're incrementing our row. Our row is kind of ticking over to the next row. And a really important thing is we're resetting this col back to 0. If we don't do that, we leave col at 4, and it's never going to pass, it's never going to satisfy the inner loop again. Okay, so I now increment my col to 4, the inner loop finishes, we increment row, and col goes back to 0. And now we're back in our inner loop, incrementing col again. We get to the end of that one row, we increment the row, set col back to 0. Finally, at the end, there's no more rows and both loops stop. So does anyone have any questions about this yet? Can you just repeat that?
Do we just, for 2D, do we just switch the 1D to 2D, basically just change the printf, and like for us here is 2D is like a rainbow color, or previously just like a roll,
Yeah, well, yeah, it's similar to the code for here. That part of the code would be similar to a 1D array where we'd just do something like that. If we had a 1D array, we'd have that exact code. We'd just be having one index and we're printing it all along. Once we've got a 2D array, yeah, we've got this second index, and to change that index as well, we need that second loop. All right, so any other questions? Yep.
I guess this is off topic, but could we utilize size of instead of rows and cols?
I don't know that size of would be helpful in this situation for what we're doing now. And don't worry if you don't know what size of is, because we haven't learnt it yet, but that's not useful for what we're doing here. Yeah, better to use rows and cols. All right, repeat the question. The question was just about using size of, but yeah, we're not going to for this. All right. If there's any more questions about this, let me know. Otherwise, we're just going to start doing some coding with 2D arrays. Okay? Okay. Okay, let's just play around with this 2D array I've got. So I've created a two-dimensional array called grid with 2 rows and 3 columns, and that's the data inside it. you know, so these would be the columns, 0, 1 and 2. These would be the rows, 0 and 1. So at the moment, I've just got it so you can play around with it. So if I enter 1, 0, and it goes to the index 1, 0 in the array, what's it going to print out? Index 1, 0 in this array. So if I go to index 1, so row 1, column 0, I should get that 2. Yeah? Is everyone clear on that? If I go to index, I don't know, 0, 1, I'm going to get what? So if I go to row 0, which gives me this row, and column 1, I should get this value 5. Is everyone happy with that? What if I go to row 2 and column 0? So row 2, column 0. Yeah. So there's no row 2. I might draw this like this so it's a bit easier. These are rows. These are cols. If I go to row 2, there's no such thing. It's going to crash. Yep. Don't worry about reading that. It's just telling us that, you know, it's gone past the end of the array. The same is if I go to 1 at index 3. So row 1, column 3, there's no such thing. It'll crash. Yeah? All right. How would I get, what is the indexes for the number 9? Everybody all at once. Yeah, 1, 2. That wasn't everybody, but it was a few people, so I'm happy. Okay. So that's the concept. Let's go on and I'm actually going to comment this part out. Let's write code to print this grid, okay? So I'm going to do it in a function. And I'm going to pass in. With these ones, I've decided, just to make it easier, I'm going to hard code these functions to only ever work for arrays, 2D arrays of these particular dimensions, right? I'm not going to pass in the size of the rows, the size of the cols. Just going to hard code it to make it easier for this example. And typically in that course, that's how we'll do it. So all I have to do is pass in the name of the array. And we're using the constants to know how many rows and cols there are. And that's defined up there. So down in my print grid function, now I could kind of cheat with an array like this. I could say, what am I doing? Well, I'm not cheating, but what's this going to do?
Is it going to print the last thing on the first line?
Well, let's see. So it does try and print something, but it's not actually printing the whole array. It's just printing 351. So it's going to row 0, but it's going through all the columns in row 0 and printing that out. So it's doing a good job. It's just not doing 100% of the jobs. We've now got to go to all the rows. And that's why we wrap this in another loop to make sure we don't just go to the first row, we go to all of the rows. We want to start at row 0. Yeah, while row is less than rows. I don't know who said that, but that was right. Smile at everyone just to be safe. So I want to do something like that. So I don't just want to print one row and print all the columns. I want to do it again and again for all the rows. Is this right? So I'm going through and I'm printing more than one row. Yeah, but I've got to make sure I put the variable in here so I'm not just always printing row 0. Also, let's try that. Also, that doesn't look very much like a 2D array. I'm going to want a new line at the end of each row, probably. Now, let's just check that that's right. Yeah. So that's how we can do it. So we're going to see, when we're working with 2D arrays, we'll see a lot of these nested loops. And this is a very typical thing to go along row by row, one by one. Okay? Hands up who likes for loops. Okay. Hands up who's scared of for loops. All right, so in the interest of everybody that likes for loops, and in the interest of everyone that's scared of for loops, we're going to do it with a for loop, just so you get used to it and you won't be scared anymore. Okay, it's the same thing. It's the same thing. First of all, I changed this word to for. Like, that part's easy. Although that's the part I keep forgetting to do when I demonstrate this. I now take this part where I'm like initializing my counter and I stick it in there in that same part. Even though in reality it's still being just initialized once before the loop. And I take this and I put this in here as well. So I've taken the 3 things and just packed them all in together. The one that was before the while loop, the one that was at the end of the loop. And I put them all in that place together, but it does exactly the same thing. When I've done it, it makes our code, one, look more compact. It also, we're not as likely to forget to do our increments, and we're not as likely to forget to reset our variables. So for these kinds of counting loops, they're really good. And now my code's sort of, once you're used to for loops, my code's also easier to read. Let's just check. Yeah, perfect. Is everyone sort of happy with that? Are people more scared or less scared of for loops now? More scared, less scared? People are more afraid, sorry. Okay, now if I want to read data into my grid, it's going to be the same thing because I'm going row by row, column by column. So I just have to, instead of doing a printf, do a scanf. And I just have to put that ampersand there. And yeah, I'm not going to want to print out that new line every time I'm reading stuff in. But it's the same structure of code anytime I'm going through the whole array. So you'll get used to this pattern. So that's my scan grid. So back up here, just for now, instead of hard coding it, I'm going to scan it in myself. And then print it, just so we see all the different things we can do. Then we'll do something a little bit more interesting. Is that right? Yep. Okay, we were able to scan stuff in, store it into our 2D array, and print it out again. Okay, what next did I have? Okay, what if I wanted to find the sum of, this is hopefully not too hard, I want to get the sum of the whole grid. I want to get the sum of all of the numbers in this grid that I've got. And again, I'm going back to my hard-coded version, so I don't have to keep typing in input. So I'm going to write a sum grid function, and I'm going to say the sum was like this. My sum is just going to return the sum of all the data that's in the grid. So how am I going to do something like this?
First we'll initialize sum to 0, and in place of, like inside the column for loop, we'll just put sum equals sum plus the grid row column.
Yeah. So did everyone hear that? No, I'm just kidding. I'll repeat what she said. That was correct. So the first thing we'd do is we'd initialize some kind of sum variable to keep track of the sum. But then basically we are just doing a traversal of the array row by row, doing the same thing, but instead of scanning in data, we're taking the data at that position and adding it on to our sum, right? So I'm just showing you a lot of this stuff, if we're just traversing through it, it has the same structure. We just change the thing inside where we're doing something to each of the cells. So we're going through one by one, looking at the data and adding it onto our sum. So we'll have 0, +3, +5, +1, etc. Oh, when I call my function, I don't do it like that. Does everyone know we can call a function like this and plug the data straight into a printf like this? I don't need to store it in a variable. This returns an int, and I just print it straight out. What are we expecting? Oh, what have I done wrong? It's saying, and this is a good error message, right? I don't have a return value. So I was a bit too overconfident, and I forgot to type in that last part. Okay. Let's try it again. Good. What's the sum going to be if it works? We always have to know, before we press enter, we should know what answer we're at least hoping that it'll give us, so we know whether it works or not, for at least this case. So what's the answer? Like, seriously. $24? Yeah, 24. Okay, so we got the sum was 24. Now, what if we wanted to find, what if I wanted to find the sum of each row? Can I write a function that returns the sum of each row? So the sum of the first row is 9. Please correct me if I'm wrong. And the sum of the second row is, everybody? 24 minus 9. Is 24 minus 9. Is 15. Can I write a function that returns both of those values?
Like we were initializing column to 0. Every time we will also initialize sum to 0. And inside the column, we will keep on adding the column elements. And then we'll print it.
So the suggestion here is that we print it, right? We can't easily return two things from a function. So for now, we'll just print both of the things out in the function. Okay. I think I'm going to go with that for now. Good suggestion. So let's call it print row sums. Okay, then we're just going to call that function. And what's this error mean? It's saying you haven't even actually written the code for that function yet. So why are you trying to compile and run your program? Okay. All right. So let's kind of take this code we've got to find the sum of everything. But we just want to we want to print out the sum after each row. So each time we've gone through a row, we want to print out the sum. So that would be here. This is at the end of each row. And I can say sum of row, I can even say what row it is whatever. So I can get my row counter and I can print out what the sum is on that particular row. Okay, let's try that. Oops. Yeah, so if you notice, if I do this, I'm getting the sum of the first row fine. The first row sum is 9, but then the second row, I'm not getting the sum of 15, right? I'm getting the sum of the whole thing. I have to go back in here and reset my sum at the beginning of each row. So for row 0, I set sum to 0. I go through the inner loop and find the sum of that row. I print it out. When I go to do the next row, I want to set my sum back to 0 again and just find the sum of that particular row. Does that make sense? So here we're tracking things and doing things row by row. Okay, and sometimes this is something you might want to do. You might want to look through every row and treat all the rows separately though. Any questions about that one? Now, what if I wanted to do it column by column? So instead of, just to, hurt your brains a little bit, in case they're not already suffering so far from the lecture. So instead of doing the sum for row 0 and row 1, we want to do the sum for this column, which would be 5. Column 1 would be 9. Column 2 would be 10. Yes. Yes. So we've had 2 people give the same suggestion. What we want to do now is instead of going row by row, we're going column by column. So here our row is the outer loop. We had a row and then we went through the columns. Now we want to have a column and go through the rows for each column. So now we kind of, reverse our loops to go column by column. Typically, we go row by row with these things, unless, sometimes you want to sum a column though. So you do it this way. So I've got to be careful. There's a more efficient way of changing all of this at once. I want to change this outer loop to cols. I'm going through one column at a time, but all of the rows within that column. Gosh, I'm making this look harder than it is. And now I'm saying the sum of this row, col. I'm printing the sum of the column each time. Okay, so we've reversed these loops, hopefully to go down like this instead of across like this. Does it work? I don't know, we'll see. What have I not done? I haven't even asked this, I haven't called the function. In fact, I haven't got a prototype either. I got a bit ahead of myself. So we've got the sum of col 0 is 5, the sum of col 1 is 9, the sum of col 2 is 10. Okay. How's everyone feeling about 2D arrays? Oh, John, you're happy with them? Okay, that's good, luckily. All right. How much time do I have? Let's get on to diagonals. So for this one, to do diagonals, it's nice to have like the same number of rows as columns. So just one more thing to hurt your brain, and then we release the assignment straight after this. Okay. So here would be I'm calling this the top left diagonal. Now, in the world of maths and other things, you might call it something else. But it's starting in the top left and going down like that. How am I going to do the sum of that diagonal? Yeah, so what are the patterns? You're answering all the questions. Yeah. If we look at the patterns, so that's exactly right. You've both said exactly the right thing. And I'm purposely not saying what it is just yet. If we look at the columns and the rows, in blue, that's what, just reminding us, these are the rows, these are the cols. I can see that along this diagonal, the indexes would be 0, 0, 1, 1, 2, 2, 3, 3. So there's a very clear pattern that the diagonals are when the row equals the col. So what I can do for this is I can go and steal my sum code from over here actually. We've got agreed with the same number of rows as columns, so we've just got one size. Now, instead of summing everything, one way to do this is just say, well, I'm only going to sum it if my row counter is equal to my column counter, because I know that's when I'm on a diagonal. Right? So I could just do it like that. And what would my diagonal sum be if it was correct? This is a genuine question. 14. Now we haven't done the other one yet. I've just got, we call this like a stub function. I've got a function there that is running, but I haven't really written the proper code for it, but it just means I've got it. I can see if the whole structure of the program is going to work. Is there any other way I could do this? Oh, this is messy. So if I just want to sum these elements, is there any other way I could do it?
We can initialize the row equal to size, and then we can just decrease it by 1.
Yeah, so for this particular one, that's I think you're saying what I'm thinking. For this particular example, we could do it without a nested loop. We could just, I'll quickly show you. Honestly though, it's really great if you could do it with the nested loop. And that's going to be more important most of the time, to be able to do things with nested loops. But occasionally, you might have a situation like this. Now, instead of calling it row or column, I'm just going to call it I for index. Okay? And I can just say sum equals sum plus, yeah, my grid at index I. And this code, instead of traversing row by row and going, is this a diagonal, should I add it, is this a diagonal, it just runs straight down the diagonal and gets the sum. Right, this one's a bit tricky, but it should give us the same answer. Now we are running out of time. I just want to get you to think about this, because we'll go through this one at the beginning of next week. I mean, at the beginning of the next lecture. What about the other diagonal? Can you think of it? We won't do it now, but can you try this as an exercise. Can you think of how we would get the other diagonal? Either as a 2D array or a 1D array. I know that you probably know it. But I won't say it yet. I'll go over it on Thursday. So that's 2D arrays. Again, this is a lot for your brain. If this is the first time you've done all this stuff, you'll practice it, and we'll do more in the lecture on 2D arrays. Don't forget, your assignment will be out in a few minutes. And here's a sneak peek. Thanks everyone. See you later.